Welcome back, everyone, and this is part 2 of our basic voxels. In a previous video, we decided to really go through the theory and a lot of things of what voxels are, how they're used, and how to build them. And we kind of build like a flat 2D voxel thing. And in this video, we're going to modify what we had in the previous lesson and bring it from 2D into 3D world. So this way we can actually get these 3D grids kind of really put together. And there's just not a lot of big code changes that needs to be done, in all honesty. So here's kind of like what our voxel looks like. And right now I left some errors in there on purpose. Like inside you can kind of see the faces. And this is basically building a box, like 3 cubes right next to each other. All the faces are drawn for every 3 faces. Ideally, those inside faces need not to be drawn. So this way you can make the proper voxel, which is very optimized voxel. And there's only some small fungi changes. Really, it's just I added a new utility called Wireframe. We had a video of maybe 40 videos ago of how to make wireframes work. So I have a wireframe utility and a wireframe shader. This allows me to really see if I'm making the voxels correctly, because like I said, I wanted to make sure that the inside stuff is, the faces are not being rendered on the inside. So I need to be able to kind of see through our shape. So that's why I kind of had this utility put together. But we've done these before. If you're really interested, just go to the GitHub to get the most, the module version of it. That's up to date that we're using for this lesson. And like I said, it allows me to see the inside of our voxel since everything's kind of gets converted into wireframe. So, let's look at some code. And I have the new code and the old code like next by, so we can kind of see a little bit some of the changes. So yeah, I'm bringing in 2 shaders. I'm actually going to use the low poly later so we can see the voxel lit up without wireframes, and we have the wireframe one, and we're loading up the module as well, so this way we can kind of convert our chunk data into wireframe data. And to get that working right, we kind of create our vertex array and an index array, and we have voxel render build the mesh right into it. So we give it the chunk, we get our V array and our I array, and that data we get that data back out, and then we can push that into our wireframe object, and we say from triangles, because this is triangle information, and we're telling it the component size, and it converts it all into triangles renderer. So it creates a new renderer just for wireframes. So for this example, we're not using the voxel renderer. We're just using the renderer to build the mesh for us so that we can turn it to triangles. And then later on, we'll actually use the voxel renderer to actually render our chunk. Let's see. So what are some of the changes we did? The constructor hasn't changed, in all honesty. If we go back here, our constructors practically stay the same. The only difference is I got rid of this. Like I said, it's garbage code. It was just there for testing. So the constructor is the same. Our coordinates function still the same. Like I said, we might not have it because I'll keep it, but I'm push the equation into our get and set functions. And we have a new set function, and all it does is it finds the cell based on the XYZ coordinate you pass in and just passes in the value. So this way we can kind of set the on and off value per voxel. And then our get function, I did some changes. So before I had this to grab neighbors, I decided to get rid of all this and simplify it down to just use our faces. So if I pass in the face value, I grab its normal and use that normal to move the XYZ position. So that saves me from doing this switch statement. So by using the normals, these normal values is exactly what I need to grab the neighboring voxels. So it's a nice little optimization, one less pile of code that needs to be done, and just like I said, I just reuse the data. So in the end of the day, I really don't need this. So it really slims down our function quite a lot. So our get function is now more slimmed down, and if I pass in this stuff, we then optimize it like crazy. So this together, perfect. Exactly what we want our get function to really be like. Let me just double check, make sure I didn't break anything. All right, good. See, I did all those things without breaking. So our get function, this is like our new optimized get function. Like I said, our set function is the same. And like I said, for optimization, I probably should do this too as well. Just pass that information in and call it a day. So I don't need one less function call when I do a set. So that's our voxel. This is the only big change to our voxel chunk. All the coordinates stay the same. And I added a component length, a new constant. So this way I can kind of control it. Down the line, I may want to change it to 3, may change it to 4. So I made a constant about it, so this way I can kind of control it instead of having everything hard-coded, like in the previous video. The only thing I changed is added a new thing called end offset. So when I'm building the quad faces, I need to know if I need to actually move them by the normal. Remember in the previous video I showed you that each face is drawn at origin. So for the front face is at origin, but if I'm building a cube, I need it to be 1 unit forward. So in the case of a forward direction, front, I have an offset to true. So when I'm building the face, I have to take this, take all this value, all the values here, I add the normal to it as well. Then I do the scaling and everything else. So I kind of have to do an offset to draw the front face correctly when I'm building the cube in a 3-dimensional way. So I kind of have certain things are true, certain things are false. Like everything that's built at an origin but at the right place by default works out. Anything that needs to be offsetted gets that offset value. So that just makes it easier to move our faces in the right places. And I believe these have to be scaled as well, because if I'm offsetting it, I need to scale the offset as well based on the scale of our voxel chunk. Let's see now, our voxel renderer. I think that's got most of the work got changed. Let's see what the constructor looked like. Our constructor was very simple. This time, it's a little bit more different. Because since I need the build mesh to do wireframes, I need the build mesh to be separated from it. So I made it a static function. And so this way, I kind of have to do the arrays, pass them in, pass in the voxel chunk, and then this thing will then create the VAO for me. So the build mesh function is actually outside. So I might, like I said in the previous lesson, I might create something called just voxel and put a lot of this stuff into voxel and have these static functions also built into voxel. So this way voxel renderer and voxel chunk will be more slimmed down and not need all this extra functionality that's kind of useless in where they are right now. So for now, everything's right here in voxel render. And let's say, so like I said, we're building it differently. So in the constructor world, like I said, we're doing this slightly differently. Now the build mesh changed. Like I said, I had to do some changes. And remember, I said previously, we're doing this in like an X and Y type of way, in a multi-dimensional array kind of way. So we're looping the multi-dimensional kind of array. And all this stuff right here, I kind of took out and made a new function. So all that stuff got, like this part of the previous, all this is what we need to build a face, right? So this creates a single face. So what I did is took that information and made a new function called append quad. So I pass in our voxel chunk, I guess the starting index value, XYZ, and then a reference to our arrays that we're going to push into. So append quad actually takes that data and pushes the data into those arrays in there. And it's practically the exact same code. Just I guess the variables got renamed. You know, we're still pushing to the array. We're scaling everything. Face index. So based on the face index, I know if I check to see if the end offset is done, and if it is, I'm taking XYZ, and by default it's 0. So when I add to it, it's 0. There's no change. But when there is a change, I make sure, do I need the end offset? If it's true, then I do the end offset, the normal offset, and scale that. Save it right back out, and then that gets applied to overall to the actual quad and triangles that we're building together. And in index is built the same way. Index, and where's index calculated? It's calculated right up here. It's calculated the exact same way. Originally, I had voxel chunk vertex length divided by 4. Now I have using that constant value, varray length divided by component length. So this way, if I ever change it to 3, everything will kind of fall into place without me doing a lot of modifications to the code. So this time around, I took out a lot of the constants, a lot of the hard-coded values, and kind of made them into something I can reuse. And more comments, too. I have more comments around. And that's, like I said, so I broke it apart, so this way we can just append quads. And our build mesh, like I said, was our loop, and here is our loop in a very simple way. You know, it's the same loop column, and when we take all that code, that append function out, it becomes a single line of code. So this whole build mesh can be done, frankly, this way. Just 5 lines of code just by breaking out the thing. But then, like I said, I wanted to, since it's a flat array, I can actually loop this all the way through. So this was the final, really the final version. So instead of having 2 for loops, I have a single for loop. So I go from 0 to XYZ length. So the entire length of the quad, the voxel chunk. And I probably didn't mention that because I totally forgot. I guess I do save an extra value, XYZ length, which is just the extra value. Like I said, since like I said, any value I'm overusing, I might as well make a copy so I don't have to do that multiplication 3 times. So I'm just looping from 0 to the total length of that array. And I actually don't really need to do it that way. I can actually just do array.length. But again, length value is a function that's called over and over again. So again, using that length value function call is another function call. So saving it as a variable that gets reused a lot. Again, it saves me a function call. So like there's a lot of little optimizations that I'm doing. That overall all adds up together to make it a slightly faster working function. So yeah, this way I loop the entire array, and if that cell, like see, I'm not even actually calling XYZ anymore. I'm not doing that call. So I'm actually able to. So if there's a lot of zeros, I can have them skipping a lot of those zeros without actually doing the XYZ mathematics. So let's see. Now. So that's okay. So now that I'm looping through the whole flat array, if I find a cell that needs to be drawn, then I calculate the XYZ values. So this is where this up here. Oh my God, where did I put it? It's voxel. So if this is the equation that takes XYZ and converts it into the integer, the index value. This does the exact opposite. This takes the index value and then converts it into XYZ. So I modulus x length gives me the new x length, the x position. And let's see. I can actually be a lot smarter, but if I want to be more optimized, but I'm doing it this way because it's just easier. But if I want to do, I can take it next step further and do a little bit more math and not have to use the get function at all. But it's easier to use the get function, really. So I end up just calculating the x, y, z. So I divided by x length. Sorry, my throat's starting to fall apart. I have a sore throat. And so I divided by x length. I get the floor value, and then do a modulus of z length gives me the new z. And the flooring I divided by x z length gives me the new y. So it's it's not very too complicated to convert index back into x, y, z. And now that I know the x and y and z of the cell I want to draw, I'm going to loop all 6 faces. So between 0 and 5, I just, here, like I said, everything is built in the right order just to make things easier. So I can actually take that north. It then kind of connects to these type of faces. Or, like I said, everything's built in the right spot, so I can actually very easily tie everything together. So since I know what my XYZ position in my 3D grid is, I just give it my face value. My face value is like north, south, west, east, up, and then down. If I don't want to draw the bottom, I just do this. And at some point, this might be controlled, because if we're doing voxel terrains, we don't need to draw the bottom. But for now, I'm going to draw the bottom because we need it. Now, I have like right now, I don't have any if statements. I'm actually going to, once I have the XYZ and I know the node information, well, I can then just append. So I pass in my voxel chunk, the face that I want to draw, what the X and Y, Z position is, and then the data I want to kind of just pass it into. These are kind of like out variables if you're into C#. So these values get pushed out. The values get saved into these arrays because they're passed in by reference. Arrays are by default by reference. So this ends up actually drawing these faces. Now, if I want these faces to not be drawn at all, I can say these two if statements are basically the same. If it's 0 or null is if null equals null, node equals null, that means that there is, like, I'm on an edge. Actually, I think this is wrong, right? No, this is right. So if don't draw, or if the neighboring node is invisible, or I'm actually at the edge of a voxel chunk, draw that specific face. And if I were to refresh that, those two faces on the inside should disappear. And there you go. They're no longer in there. And I can actually kind of go in there a little bit. So I'm inside this voxel, and the faces are gone. If I comment that back out, refresh. If I want to, I can then zoom as well, and you can kind of, it's kind of hard to, I'm inside of it, so you can kind of see the faces a little bit. It's kind of hard to tell, but I'm inside, and the faces are there. So if I, like I said, if I comment this back out or put this back in, I should be able to see a nice hallway to the other side. So it's a nice hallway. There's no extra faces being drawn. So this is a perfect voxel. It's a very optimized voxel. That means I only have the faces that need to be rendered. So that's a perfect voxel. Now, the reason why I have two ifs, and like I said, I'm all about optimization. So I look back at this as like, okay, this is when I want to draw. So basically, I can say, well, this is when I want to draw. When do I not draw it? So if it equals 0 or if it equals null, there's only 3 values, basically. Well, here's the thing. Node can return me 3 values. It can return me 0, it can return me null, or it can return me 1. I get 3 values in return. So if the 2 values, if these are the 2 values I want to draw on, that means I can just say, well, if it's not 1, if it's not 1, then draw it. So if I use like a kind of a negative condition, like a polar negative condition, or some people don't like using knots, but I do. I do, cause, like I said, because I can actually save an additional condition. So if it's not 1, then draw it. If it is 1, don't draw it. Because don't draw that face. Because I'm actually getting the neighbors. That's what I'm doing here. So by doing that little thing, I just make the if statement a little bit smaller, and I get the exact same result. So by just doing kind of like a negative check. So like I said, node returns 3 values, and if 2 of the 3 means to draw, then just say not that third value. If you're not that third value, that odd man out, draw it. And that means I can write this into very, very simple code. And like I said, I don't need this loop because I like using a single array loop. And our build mesh is now very, very optimized. It could be a little bit further if I want to do the math in here instead of using the get. I could probably use this math without doing this function call, but I don't know. There's no reason for me to do it. There might be a way to just like I need to do like a little bit of math. So I take the index, and if I say I want north, I have to say like a whole grid behind me. If I want to go east, east, I go a grid in front of me. But I then also need to check to see if I'm not accidentally going into the next row, or if I'm like basically going out of bounds. So that's kind of why I kind of kept get, because get has all that functionality in there in all our checks. It has all the direction things, and it does all the checking. So I really don't feel like there's, and if I really wanted, I can copy it so there's one less function call, but this one extra function call is, I think, is important, so I don't need to go that insane. And then it makes the code not a lot very neat. So I kind of like how this is overall is built. It's done with. I think I've done all the optimization that I feel comfortable with. I don't need to go overboard with it. To get rid of one whole function call and end up duplicating the get function. So that get function does the job of what I need. Like, it gets me the data, gets the neighbor, and it checks for out of bounds and everything else. So I can get to tell if it's a null value. And and like I said, that's all it takes to build a voxel. And that's it. We're done. Now I can kind of quickly show you some quick demos, I guess. So do a 3x3 voxel, and everything's set to on, so I just do a bunch of offs. So I set a bunch of things to offs, and that creates this. It's probably hard to tell, but if I were to switch over from Wireframe to Phong lighting, and I'm using our voxel renderer, there may be a slight seam, which I would need to fix that at some point. These need to be perfect, but overall they're pretty good. Yeah, I hate the seams. I hate when the little seams are in there, based on the direction of light. But yeah, there's our voxel that we can build, and I kind of built it where I kind of have like tunnels like cut right through the center of the cube. And the other one I put together, let's see. It's kind of like the exact opposite, and I just took out all the edges, and so I ended up creating this shape. So yeah, that's pretty much it. That's really all to it. Like these two classes is everything you need as a starting point to build voxels. It's like I said, it's the starting point. This is how do you render it. Basically, how do you take the data and render it? And voxel chunk is data in general. And like I said, it has a nice all the little tricks and things to make it very easy to kind of just loop through and build everything. And like I said, the two objects are very small. There's 1, 2, 3, and this probably has another 3. Yeah, it's 6 functions total. It only takes about 6 functions to really kind of handle voxel, and a couple of constants. That's about it. Not including the whole fungi engine that we built in the last year, but overall, just for voxels in general, it's very minimal amount of code, and really mathematics. There's not much to it, especially since the approach we went with flat arrays. We kept everything to the bare minimum, and we made it very fast. Like I said, this is one loop, and we don't end up doing any math at all, only when we need to. So we only do it when we're drawing. So I think the previous example we kept doing the get call, no matter what. So yeah, there's probably a little, like I said, I might break this out into 3, and then make a module out of this. So when we're moving forward, I'm not exactly sure what I'm going to move next. I might do rake casting with voxels, so this way I can maybe start selecting voxels, or at least maybe point and click a voxel, so I know which one I'm picking and maybe know which face I'm clicking on. Let's see if I can research that and do that. I might do that next. I don't know if that I may need to do octrees before to accomplish that. So if I need to do octrees first, I might do a video for octrees first, explaining it, how to put it together, and maybe do some debug visualization of octrees, and then do rake casting, which then you can use all that information, and then so if I click and point, maybe I'll end up building voxels in those exact spots. So that might be the next thing, but next video might be it's actually going to be about armatures, because I just finished doing a keyframe animator for armatures, so we can start animating armatures a little bit, coming from Blender. So I'm going to show you how to build a bare bones keyframe animator in the next video, and then after that I might do Blender stuff that's imported, and then maybe make Bendy walk, and maybe build a character controller, or I might do voxel rake casting, rake collision with voxels. So I'm one or the other. So, but the next video is definitely going to be about keyframe animations, how to implement a very simple keyframe animator, and then repurpose that to make a very specific keyframe animator just for armatures, because I want to keep them separate. In the next video I'll probably explain why I want them separated. But yeah, so here you go. Hope you guys like this. I had to break this out into 2 videos because there's really a lot when it comes to voxels. Like at the end of the day, there's not a lot of code, but it's a lot of ideas and theories that goes into it, and there's still so much more. Like there's marching cubes, and I think marching cubes I think it's supposed to make things smoother. Arching cubes. I think that's what it's supposed to do. Like something like that. So instead of it's not so blocky, you kind of like smooth things out a little bit. So that's what marching cubes does. So I definitely want to explore that. Like it works really well when it comes to terrains. That's what they're for. It's just like I said. It's instead of making it so blocky, you can smooth things out a little bit. That's what marching. So instead of being like this, you can make it neater looking. That looks really nice. I like how just the lighting and the textures are put together just right. Yeah, it's another good example of marching cubes. I don't know how to do it yet. Like I have to research it and get an understanding of it, and then prototype it. But that will be somewhere on the in the exploration of voxels. Like I said, I don't know if I should do rate casting or what do you guys want to do? Do you want maybe me to do that before I do rate casting? Um, this is not really that important when it comes to making the portal editor. The rate casting is important because I need to be able to select voxels. But I don't know, but if you guys really want marching for some reason, makes you want to kind of get started with terrains on your own, I can work on that if you guys prefer. Just tell me in the comments if there's a very specific thing. I would do a poll, but I don't have 2,000 subscribers yet, so I can't access some of my YouTube functionality until I reach 2,000 subscribers. So please like and subscribe, because the more subscribers, the more YouTube features I can use to kind of facilitate a lot of the community stuff. Like, make it easier to do polls and whatnot, and ask you guys questions, like a community tab. So yeah, that's it. I hope you guys enjoy this video. Actually, making actual voxels. It's kind of like the good basic starting point of a voxel system. Like I said, there's a lot more to it down the line. We got to fix those seams. Not exactly sure how to fix those seams unless I make sure the points are exactly alike. They have to be exactly alike. That's about it. So with those points being exact, the seams will disappear. I don't think it's the lighting. Could be the lighting. I'm not sure. Like I said, something I have to do. Oh, like that's right. We can go inside. We can see what it looks on the inside. That's kind of neat. So yeah, like I said, the everything we've done, just drawing the faces, does an awesome job. So yeah, they draw. So you can, like I said, it's pretty neat. So again, like and subscribe. So I'll see you guys at the next video. Hopefully it'll be more about keyframe animations. But I hope you guys are enjoying voxels, and tell me if you guys this is where you really love this. If this is a topic that's really important to you guys. All right, see you guys in the next video.